Hey guys, it's me. I'm going to have you guys take some notes today on intermolecular forces. So you should have notebooks out with a pen or pencil. And this is still falling under the category of covalent bonding, but it's a special subcategory that we're going to be talking about today. So if you can write the title Intermolecular Forces, or IMF for short. And we're going to first talk about what it means, because that title sounds awfully intimidating. But if you think about an analogy for it, if you guys have ever driven on I-94, you've driven on an interstate highway. And so I want you to think about what the word interstate highway means. An interstate highway is a highway that goes between states. So I-94 isn't just in Minnesota, it's in North Dakota and Montana and Wisconsin and so forth. So it's an interstate highway, is a highway between states. So think about intermolecular forces for a second. An intermolecular force is a force of attraction between molecules. Again, a force between molecules. And so if we write down the definition, it's an attraction or force between molecules. It's not a true bond like ionic or covalent bonds. We've been talking about this chapter. So again, it's an attraction between molecules. And it's not a true bond like ionic or covalent. And what's interesting about intermolecular forces is they're forces of attraction that hold molecules together. So if I have one water molecule and another water molecule, they're actually not just attracted, the atoms within them aren't attracted to each other, but if I have one molecule of water, it's actually attracted to another water molecule, and they can be held more closely together because of that. Now you do need to know they're weaker than bonds. So the forces within the molecules are bonds. Those are stronger than intermolecular forces, but they still can do some interesting things. What they cause are some really interesting property differences between compounds. So boiling point, surface tension, it can change things like how much they evaporate, how quickly they evaporate, things like that. So again, intermolecular forces, they're forces of attraction between molecules, so one molecule and another molecule. They're not as strong as the bonds that are inside the molecules. And because different compounds have different strengths of attraction, so like different strengths of intermolecular forces, you can cause property differences between different compounds. So for instance, compounds that have really strong intermolecular forces of attraction between those molecules are going to have different properties than those that have weak intermolecular forces between them. All right, so what are the property differences? So if you guys want to make two columns in your notebook, one for low IMF, so that's really weak intermolecular forces. So that's when you've got like molecules that really aren't attracted to each other very much. And then another column for compounds that have high or strong intermolecular forces. So those are molecules that are really attracted to each other and have high forces of attraction between them. So we're just going to compare the properties. A column for those with weak intermolecular forces and with strong. So if I have a compound that has weak or low intermolecular forces, they're going to have really low melting and boiling points. If you think back to that lab we did at the beginning of the chapter and how we tested the melting point on the tinfoil, you guys might remember that some of those compounds melted really, really fast. Well, if I have a compound with low IMFs, it's going to melt really, really fast. It might have a very low temperature of melting, and it also might boil really fast as well. Okay? If I have high IMFs, it's going to be a little bit different. All right, low IMFs also tend to be liquids and gases at room temperature, okay? Because their compounds, or the molecules within the compounds aren't as attracted to each other, they're not going to have as much density because they're not going to be packed in as close. And so because of that, they're going to have a tendency to be liquids or gases at room temperature. They have low surface tension. So if you've ever done that activity where you find out how many drops of a liquid you can put on the head of a penny, if you remember that from way back maybe in middle school, low surface tension means you're not going to get that many drops on the penny. You might get 10 or 15, and then you can't add any more. So low surface tension. And then compounds with low or weak IMFs tend to evaporate really quickly. So if I have a sample out, it's going to evaporate quickly. All right, high IMFs. So high IMFs have high melting and boiling points. See how that's different. So think back again to that lab. If I had a covalent compound with really, really strong intermolecular forces, it would have taken more energy to melt than those with weak intermolecular forces. Because they have higher intermolecular forces, there's a bigger source of attraction, and so those molecules, since they're more attracted to each other, are going to be closer together. Since they're going to be closer together, they're probably going to be liquids or solids at room temperature. They're going to have high surface tension. So I want you to think about water. Water is a great example of a chemical that has really strong intermolecular forces, okay? If I were to put drops of water on a penny, I would probably get somewhere between 25 and 30 drops of water on a head of a penny before that surface tension breaks. If you ever think about adding water to a glass and the fact that you can actually fill it past the top and it bubbles up across the top, that means that it has strong or high surface tension, which comes from those strong intermolecular forces. And then finally, it evaporates slowly. So if I had some water sitting out and then another chemical that has low IMF sitting out, the water is going to evaporate more slowly. So I'm going to keep that water in the container longer than if it had low IMFs. Okay, so quick recap. IMFs are called intermolecular forces. They're forces of attraction between molecules, so from one molecule to another molecule. They're different than bonds. Remember, bonds are those forces of attraction between atoms within the molecule. So the IMFs are weaker than an actual bond, but they can cause property differences. And we've seen the list of property differences, okay? You're going to get a short homework assignment, and by short, I mean it's 3 problems long in your packet to answer just a couple questions about IMFs, and then you'll be done for the day. Thanks for listening.